Hi guys, today's lesson is on metal oxides. And today we're going to start off with a very simple question because it's the start of a new topic. What does this show? So pause the video, have a think, then unpause and we'll go through the answer. Well, this picture here shows rust. Now hopefully you guessed that. What you might not know is that iron is the only metal that rusts. Lots of metals react with moisture and oxygen in the air and form a similar thing, but we don't call that rust. We say that the metal has oxidized, and that's what we're going to focus on in today's video. So before we get started, where do you find metals on the periodic table? This should be a bit of a recap from year 9. And hopefully, if you can see a periodic table, you'll notice that all the metals are on the left of the stepped line. And that's important because as we go through some of the worked examples today, you need to know that the things that we're reacting are indeed metals. Now usually if I was doing this as a lesson, I'd do it as a practical. But since we can't do it as a practical, I'm going to talk you through it with one example. Here we have an iron rose. And we'd look at the metal to start with and we'd say, well, what does it look like? Well, it's silver and it's shiny. If I then take some tongs and put it into a blue flame using a Bunsen burner, what we'd see is that this metal would start to react with the oxygen around the Bunsen burner. So after about a minute, we'd take it out and we place it on a heat-proof mat and then watch or look for the differences. What you'll see is that an oxide layer has formed around the metal, like a chalky or powdery substance has formed around the metal. Sometimes this will be grey, sometimes it'll be white, but it will always be kind of like a chalky material. And we call that an oxide layer, and this will happen with all metals. Now we know that when a metal reacts with oxygen, it forms a metal oxide, and this is called oxidation. And this is quite simply just gaining oxygen. Now we're going to look at the general formula now, so you can write the product of oxidation for whatever metal you're presented with. So copy this down, and then let's have a go at the example. So here's the example. Copper plus oxygen forms what? Well, copper's the metal, oxygen always stays as oxygen, and it always forms a metal oxide. So we write the name of the metal plus oxide at the end. So the metal is copper, and when it reacts with oxygen, it forms copper oxide. Now that's quite straightforward. You could do this for most metals, but it gets a little more tricky when we ask to do a symbol formula or even a balanced symbol formula. So let's have a go at that now. The general formula is there at the top for you, and here's another example. We have magnesium reacting with oxygen, and this forms magnesium oxide. Now the symbol equation would be magnesium, so Mg, remember capital M, little g, plus oxygen. Now oxygen's diatomic, so it actually exists as O2. Then the arrow, and we have to write magnesium oxide, and that's Mg. And the reason it's MgO and not MgO2 has been explained in a previous video. But just to go through the basics, it's MgO so that the charges balance. Magnesium forms a 2 plus ion and oxygen a 2 minus ion. If it was MgO2, i.e. you've just pushed these two things together, then the charges wouldn't balance. Mg would still be 2 plus, but now we've got 2 minus ions. Now overall, that's 4 minus. That doesn't balance. So that's the reason it's MgO and not MgO2. So that would be your symbol equation. Mg plus O2 goes to form MgO. But now we need to balance the symbol equation. Because if you look, we have 2 options on the left, but we don't have 2 on the right. Now again, this has been done in a previous video on balancing equations, so I'm only going to do it quickly here. Mg plus O2 goes to form MgO. Now we need 2 options on the left, so I'm going to put a large 2 at the front of this compound. That multiplies everything to the right, so now we have 2 magnesiums, but we also have 2 oxygens. So that solved our problem. We have 2 oxygens on the left, and we now have 2 on the right. But that's messed up or created another problem for our magnesiums, because we have 2 magnesiums on the right, but only 1 on the left. So to balance that, we put a big 2 here as well. Now that's balanced. So I've got some here for you to have a go at. Iron and oxygen, zinc and oxygen, and sodium oxygen. I want you to start by using the general formula just to fill in the products. And once you feel a bit more comfortable, try a symbol equation, and then if you're really comfortable with this, try a balanced symbol equation. So pause the video, have a go, then we'll unpause for the answers. Okay, so the answers for this, iron plus oxygen will always give you iron oxide. And if we were going to turn this into a symbol equation, the symbol for iron is Fe plus O2. Remember, oxygen's diatomic. Goes to give FeO. Now if we were going to try and balance this, it would be the same as the last one. We have 2 oxygens on the left, but only 1 on the right. So we need to double this here. And we also need to double our number of ions on the left. So we have 2 ions on the right and also 2 on the left. To do zinc and oxygen, it would be zinc oxide. And to turn this into a symbol equation, zinc is Zn, oxygen is O2, goes to give ZnO. Now hopefully you see a pattern. To balance it, it's a 2 here and also a 2 here. This last one is a little different. It still has the same product, and you follow the general formula. Sodium and oxygen gives you sodium oxide. But the balanced symbol formula is slightly different, so we'll look at that now. Sodium is Na. O2 for oxygen, that stays the same. Now this goes to Na2O. And the reason for that is the same reason that ZnO is not ZnO2. The charges have to balance. Sodium has a 1 plus charge, so having 2 of them gives us an overall 2 plus. Oxygen is 2 minus, so they balance. But our overall symbol equation isn't balanced. We've still got 2 oxygens on the left and 1 on the right, so we have to multiply this by 2 to double our number of oxygens, but doing this also doubles our amount of sodium, so we now have 2 times 2, so 4 sodiums. So we need to add a 4 on the left here. So slightly trickier, that last one there, but still doable, and at least if you can just remember the general formula, you will always be able to work out the product. Now we're going to finish off with 4 questions for you to have a go at. Remember, if you get stuck at any of these, put a comment in the box below and I'll do a worked example for you. See you later.